Hey everybody, I hope you're all doing well and healthy. I know you've missed me, so I've been sending you videos off YouTube. Well, I'm making my own because I know you miss me so much and you want to see this amazing face. There you go. We've been talking about motion and forces. Okay, a force is a push or a pull, if you remember that from some of the videos I've sent. So I have a frisbee. Okay, if I throw it, I'm pushing it, right? What's pulling on it? We have the pull of gravity, pulling it down towards the earth. We have a pull of wind resistance, because it's going that way. Which way is wind resistance? It's going to be the opposite way. Remember, wind resistance is like friction. One of the other things that we've been talking about is Newton's first law of motion. Objects at rest will remain at rest. An object in motion will stay in motion unless acted upon by an unbalanced force. In this case, we're going to talk about objects in motion. The unbalanced force is going to be wind resistance or friction. So I'm going to throw this frisbee. And what's going to happen? Is it going to continue on forever, or is it going to eventually stop? Probably eventually stop, right? We all know that. Throw a baseball, throw a frisbee, whatever, it eventually comes to a stop because of unbalanced forces acting the opposite way. So here we go. We'll throw the frisbee. So as you can see, what happened? First of all, the frisbee slowed down in its flight because of the wind resistance. And then obviously, me, being an object, put a force against the frisbee, which caused it to stop. Now, what would happen if we did that in space? If I threw it, what would happen? It would continue on forever. You saw the first part, or a part of Newton's first law of motion, where an object in motion will stay in motion unless acted upon by an unbalanced force. In this case, the frisbee was acted on by the wind or the wind resistance. Okay, and then me, I stopped it dead in its tracks because I'm like that, tough. Anyways, put force on it, stopped it. So now we're going to go to the second part of it, or the other part of it, which is objects at rest will remain at rest. Now these ones, try at home. You know, there's a couple that, if you break some things, I didn't tell you to do this at home, but go ahead and try it at home. All right, so first I'm gonna start with barbecue sauce, which I'm not opening. It's just part of the experiment. I have two pieces of paper here. One's smooth and one has sandpaper on it. And then I have some pennies. Okay, one thing that affects the first law of motion is friction. Okay, we talked about air resistance and friction so far. Something about friction is the faster something moves, the less friction there is. So I'm going to put this little piece of paper on top of the barbecue sauce, put a stack of pennies on top of the barbecue sauce, and I'm going to pull it out from underneath the pennies. Now I moved it fast enough to where there was no friction or very little friction, so there wasn't enough of an unbalanced force to move the pennies. So the pennies remained at rest. Like the law says, objects at rest remain at rest unless acted upon by an unbalanced force. There was no unbalanced force to move the pennies. So now I'm going to try sandpaper. What's that going to do? That's going to increase the friction. So we're going to put the pennies on the sandpaper and we're going to try the same thing. As you can see, some of the pennies didn't quite stay because of the roughness of the sandpaper. These pennies flew off with the sandpaper. Obviously some stayed behind, okay? But because of the increased friction, I couldn't get all the pennies to stay. Try that at home. Here's the second thing. I have 3 blocks. 1, 2, 3. I have a stick. It's a beautiful stick, I know. And I have a water bottle. Now what I'm going to do is set the water bottle on top of here. Now the goal is to knock these blocks out from underneath the water bottle, allowing the water bottle to stay in place. So if I move fast enough, the block should come out with very little friction. Oh no! So if I hit these blocks fast enough, the water bottle should stay in place and just drop. So let's see. Woo! Woo! Oh! One more time. When you get good enough, maybe you can do this. That's right. What happened? The water bottle stayed in place. Object at rest remained at rest. because I took away friction with my incredible lightning speed. So this next one's really easy. Get some pennies, put them on your elbow. You gotta balance them. Turn your hand this way, and then you want to catch the pennies. So when you get good enough, you can take a big stack of pennies. It's about 25 pennies here. Put them on your elbow. And catch them. All right. Now, what happened? Objects at rest remain at rest, right? So if I move fast enough, gravity doesn't have enough time to pull on the object very fast, and I'm able to catch the pennies because those pennies remain at rest because they're not accelerating fast enough. These next two, try them at home if you want. It can be messy. I'm going to show you how to do it. It's up to you if you want to try it. Ask your parents first. You didn't hear it from me. This is called the egg water landing. And take a cup. I'm going to put some water in it. Almost to the top. Not quite, but almost to the top. And then take a pie plate, pie tin, put it on top. Put this little cup on there. I'm going to move it right over to the edge so that the pie plate is over the edge of the table. Now, I'm going to take an egg. I might need some energy for this one. Let me get a real egg. Put the real egg on top, just like that. Make sure it's right over the middle of the cup. And I'm gonna grab my broom. Take the broom and I'm gonna step on right there. I'm gonna get it close to the table. I'm gonna pull the broom back. Now hopefully what happens is the broom, so, step on the broom, okay, pull it back. You want to get it kind of close to the table. Pull the broom back, and hopefully it will hit the pie tin, up under the egg, and the egg falls right into the water. There you go. Let's do that again. This is the last one. This is my tablecloth. I just use a sheet because I don't really have a tablecloth. But my tablecloth, I have a full place setting. I have a plate, a bowl, a cup, little plate, some silverware. Okay. So you can do this at home if you want. Use your mom's best china. Doesn't matter, right? Because you're not going to break it. Don't do that because I don't trust any of you. Here's the thing. For this one, it's an all or nothing thing. You can't go halfway and then freak out because it's going to pull the plate. So what's going to happen? If I move fast enough, I'll get rid of the friction. Everything should stay in place, right? It should stay at rest. If I don't move fast enough, there's going to be a big crash. So here we go. Now remember, it's an all or nothing thing. You got to grab the tablecloth and you got to pull. Woo! That's right. That's right. Just like it was set. Just like nothing ever happened. That's a beautiful thing. Right on. That's Newton's first law of motion. We went over objects in motion will remain in motion unless acted upon by an unbalanced force. The frisbee, right through the frisbee, the wind resistance, which is basically friction, fluid friction, slowed it down. And then when it got to me, which was an unbalanced force strong enough to stop the frisbee, it stopped. So unbalanced forces change the motion of an object. Now again, if we did that in space, we threw the frisbee, it would go the same speed, the same direction, and would not slow down forever unless it was acted on by an unbalanced force. The other part, objects to rest will remain at rest unless acted upon by an unbalanced force. We did lots of those. We did the barbecue sauce and the pennies. We did the blocks in the water bottle. We did the pennies on the elbow. We did the egg water landing, and we did the place setting and the tablecloth. So on all of those, speed was a huge factor because the faster something moves, the less friction there is. So if you move things fast enough, those objects will stay in place because of inertia. Inertia being the first law of motion. Objects at rest will remain at rest. So when I went fast, there was no friction, there was no unbalanced force to move them. Again, if I went slow, what would happen to the plates and everything? They would go crash into the floor. Now I don't want to do that because I don't have very many plates. But if you try this at home, remember, you have to pull that all or nothing. But if you do break the plates, it's not my fault. Tell your parents it wasn't my fault. Anyways, I hope you enjoyed this video, and it was great to have you guys watching. I hope you guys are learning a little bit of something from science. I hope you're doing well and staying healthy, and hopefully I'll see you before the end of the year. See you later.